Okay, so from popular request by my students, this is a tutorial on going Forma to Revit to physical model, and we're not going to go all the way through the physical model, specifically a topo model, but you will get the idea in terms of how to set something like this Forma file up for laser cutting. Um, a terrain or topography model. So um, Forma is excellent, and it gives you really good topo lines. Essentially, you are going to be sending one of your proposals directly to Revit. The process is really simple, and that is the three dots here, Revit. If you haven't installed the add-in, you have to do that first, and then send to Revit. The rest inside of Revit is really simple. Massing in sight, you're going to go load proposal and load proposal, and it will show up and give you this, which is pretty amazing. Again, excellent topography. All the massing comes in. Everything that you've built in Forma shows up, and it just works. So from here, the next thing that I need to do in terms of setting this up for laser cutting topography lines and getting all of this data carried across is to build a laser page to essentially isolate how much I want, what scale I'm going to have, all of those kind of things. So for that, I'm going to go to Sheets, right click and New Sheet, and I'm going to load my laser cutter sheet. Which in our case we used a thunder laser, which I would actually say is an awesome laser for anybody listening. Really amazing quality, great laser. And we have a 23.6 inch by 35.4 inch bed, so we set that up as our page and say OK. So from here, if I look at this as a 3D view, what I get from Forma is a little bit weird in terms of how it behaves. Level 1 looks okay, except typically I want my topography, my topo solid hidden. Level 2, same kind of thing, except I would typically want this hidden. For some reason or another, the site shows up absolutely nothing. So let's fix that part first. I'm just going to delete that site view. I'm going to go to an elevation view, and I'm going to zoom in, and I'm going to grab my level view, my level 2 view, and we're just going to send that 90 feet vertically. Could be different in different scenarios here, but that gives me a cut plane that is just over 100 feet high, and I'm just going to rename this site. Okay, so I need to add this in. That's not automatically going to show up in my plans list, but if I go to View, Plan Views, and Floor Plan, I will see Site as an option. And that will create a view for me, which then if I reveal hidden elements, you'll notice we still have absolutely nothing. And that is because the next thing that we need to do is set the depth on that view. Again, it stops by default a few feet on the floor below it. And that is located, I've got to remember what it's at. It's view range. That's what it is. View range. I'm going to click edit. And to be honest, I don't remember which one this is. I'm just going to set all these to unlimited and apply and OK. And so that allows me to see essentially past a basic cutoff depth all the way down unlimited, which is what we want out of a site plan view. So now I can see my topo solid. I'm at 1/8 inch scale, which I know for a site model is probably a bit ridiculous. So let's just change this to a 1/16. And now what I can do is let's go ahead and crop the area that we want, which that's my building site right there. I want to get a few blocks worth of context. So what I'm going to do is go crop on all of my key things, crop view, crop region, and annotation crop. And I'm going to pull each of those in. Isolating essentially a couple of blocks in each direction that I want to build for this site model. Something like that. So this, as my site view, is now ready to drag and drop onto my laser page. So there's my laser page. Let's go to my site view, drags, drops, and we have something like that. We realize that also a 1/16 of an inch, way too big for this. Okay, so let's look at maybe 1 to 50. Let's go back to my site. Let's drop this down. 1 inch equals 50 feet. And move that in place. And, you know, I think I can get by with this. It's not showing maybe quite as many blocks as I'd like to. It feels about right. So I'm going to go ahead and move that tag in. I'm going to left click on my view, right click and say activate view, so I can move my cut plane here, or my crop I should say, inside of my laser page. And then right click and deactivate view. And let's move that title in here. And slide that over. Okay, so what I have now, I've got my site, I've got my buildings. Unfortunately, these roads are not accurate in terms of their width. They are indicators in Forma, but they are not actually the right width. I could come in and change those by resetting it, but I'm probably just going to hide them for right now. So let's go back to my site view. And I need to set up a couple of things now at this point. I am assuming that this is going to be a chipboard model, and chipboard models are, chipboard's approximately a 1/16 of an inch thick. So if I do a bit of math, I'm at a 1 to 50 scale. So I know 1 inch equals 50 feet. Right, so I can do 50 as my first number. I know I've got 16 stacks of chipboard for that same 1 inch. So if I take 50 divided by 16, I know that each layer of chipboard equals 3.125 feet. Okay, so by the same token, if I was an 1/8 inch model, to clear on that, if I was an 1/8 inch model, I would have 8 divided by 16, or 0.5. Each layer of chipboard would be 6 inches. If I was a 1 to 100 model, I would have 100 divided by 16. Each layer of chipboard would be 6.25 feet. So I can use that to set my contours, right, inside of Revit in terms of how often it's drawing contour lines and what dimension those are at vertically. So let's go back to 50 divided by 16 is equal to 3.125 feet. So I'm going to select my topo lines, and I am going to go edit type. And I should say I'm not selecting my topo lines, to be specific here. I'm selecting my topo solid and then going edit type. And then under contour display, I can click edit, and we are going to get rid of one of these. We don't need intervals, so I'm just going to go delete. And then on my interval, I'm going to go 3.125 feet and then hit OK. And when I hit OK again, we'll see those lines update. Much fewer lines. Cool, far fewer lines now. So my next step that I can do, I've got two ways that I can approach a model like this. The first method is to simply and quickly retrace these lines, which is something I can do. But it's also something that I'm, might want to build this as an evens and odds kind of setup. And we'll look at that as the next method here. So, or essentially we build up a hollow model. So to do that, if I wanted to trace this, the first thing that I need to do is I do need to hide these roads while I'm tracing out. In fact, you can even see the roads inside of Revit. They are designed as a 1 foot elevation above the surrounding topography. So it's just doing some general wackiness. So I need to select those, hide the elements, and I should see the contours as a much more even kind of thing now. So that's super helpful. what I would do is I would come in, if I just want to use the tracing method, I would do manage, and then I would do additional settings, line weights, and I would add, not line weights, come on Dave, line styles, thank you. And I would add a new subcategory, and I would name this laser topo cut, and say okay, and I would make that probably obnoxious green. Okay and okay. And so pretty quickly from this, I would do annotate detail lines on my line list, laser topo cut, and then I would just do my best to go screaming fast through tracing these. I would not be as accurate as I should be, but I would be as accurate as I need to be for topography, which is, accurate-ish. But what you want to think about is exactly not what I'm doing. Oh, and I just traced out a building there, not a topo line, so that's not the best. What you really need to be thinking about doing is thinking about this as layers of chipboard or cardboard or whatever you're building a model out of. So I would actually take this first piece that I did, just that. I would go detail lines, and I would want to start someplace up here in the corner and trace down, and I really need to be thinking about making these as individual shapes so that they are individual layers of cardboard or chipboard. And each time I have that layer, let's turn off my crop line so I can see this a little bit better. Okay, each time I create a topo line sketch, essentially, I would go copy, and I would move that off to the side. Okay, so let's turn our crop views back on. And let's get that next layer coming together. And to be able to trace underneath the buildings, I might switch that to a wireframe view. And it looks like this piece is also this piece. I think probably should have started here. That'd be a little easier to see it coming together. So let's trace out something like that. So I do annotate detail line. Again, I'm going to grab a common point right there. Let's trace. That, and let's get this point from here to here, and trim those last two pieces together. And then I'm going to leverage my tab key to select all of that, copy, so way out to the side someplace. Let's turn our crops off. So we can see how those two layers start to match up. Right, so that gives you the idea that one of these, oops, move. You can start seeing how this would stack on top of that, so on and so forth. So again, I can make all of those pieces, trace them out quickly, cut each one, essentially lay these out onto a laser page, cut each one individually, and lay them out. Now, stack them up, glue them up. Okay, so that is a method. It works great, makes for a nice clean model. It isn't the fastest way to do this, though. Okay, so the next method to look at is the evens and odds methods of building a contour. A lot faster on working with the laser, and it allows you to only leverage 2 pieces of chipboard or 2 pieces of cardboard. So what I'm going to do with this is I'm going to actually leverage the exact topo lines, and we will create essentially, and I say evens and odds because usually if we're doing 1 foot contours, we would be cutting lines 1, 3, 5, 7 and engraving lines 2, 4, 6, 8. That's why I call it the evens and odds method. In this case, since we're a 1 to 50 model using 16th inch chipboard, evens and odds doesn't really work as a strategy in terms of name, but hopefully you'll understand where I'm going with this. Okay, so I'm going to select my topo lines again and click Edit Type, Contour Display, and let's insert another group of contour lines. We will call this one Primary Contours, and we are going to do it at 6.25 feet. Okay, so exactly double this. So we've got secondary contours, primary contours. If I say OK and OK, you will notice as we zoom in, every other contour is a slightly wider line. That's because I've got primary contours and secondary contours. With this, I can go to Manage and Object Styles. And if I come down to my topo lines on Topo Solid, I can take my primary contours and I'm going to set them to laser green. I'm going to take my secondary contours and set those to laser cyan and say apply and OK. Now I have something set up so that if I turn my crop back on, and I go to my laser page, you can see that I can send this now in such a way that I could say cut the greens, engrave the cyan, and then I could send a second pass that says cut the cyan, engrave the green, and that would allow me to stack those model and make a hollow topo file all the way up. And I can take that a step further as well. It's really nice having those building outlines. If I wanted to engrave those on everything, I could also go to Object Styles. Those are generic models. So if I just come down to generic models and say black, let's change those to blue. Now I could say engrave the cyan, cut the green, engrave the blue. And then I could say engrave the green, cut the cyan, engrave the blue. On every single pass that I send, I would always have the blue lines as engraved, whether they're on either version of the topo. And I could do the same thing with the roads as well and say that red color also is always engraved to get an indication of exactly where those roads are. And so that's essentially the method that I would use if building that quick, simple, easy. I can leverage the data that I'm getting from Forma and turn out a model really, really fast.